Hello, Code Europe. What's up? Great. Okay, so I'll start as soon as possible, and I'll finish on time, hopefully. First of all, I want to do something very regular. When you're coming to a company and you're starting working on your web pages or on your applications, what the first thing that you see? A design. For example, you can see here a design of some web page. Okay, so what are you going to do when you get that design from the designer? Let's see. So if I want to go and drill down into one section in this page, what I'm doing is, first of all, I'm moving from the design to the implementation. How I do that? I break up everything into cubes. Okay, for example, a session list from this slide, okay, is becoming something like session details and speaker details and session filters and etc., etc. Okay, that's easy. So let's drill down much more or further. We can look at this as component with some child component. Yes, of course. And we can break it into some components as we are used to in HTML, for example, if it's a web page. So we'll have a session list, session details, speaker details, and session filters component. That's cool. But how would you build that page with all this mess on top? Do we really need these libraries and frameworks when we are programming a web page or a web application? What if I'll tell you that you can teach the browser new elements and use those elements? Every element instance is supposed to be a DOM element with its own properties and function and everything else. It's an instance. It is written in JavaScript. Is it possible? This is the time that you say, yes. Okay? Yes. Okay, it's possible. And this is where our journey begins today. A little bit about myself before I'm drilling down into what we're going to do today. So one, I'm Gil Fink, as was pronounced. I'm Spark's CEO, and I'm a senior consultant. I'm a Microsoft MVP for the last 8 years. It's an award. It's not some test that you do. I wrote a book called Pro Single Page Application Development. If you saw that in Amazon, cool. If you didn't see it, you can find it on Amazon. It's still selling, and it's with Backbone. So if you are coming from a background of Angular, React, Vue, whatever, it's in Backbone, but it will teach you the specific ways to build single-page applications, SPAs. Okay, so Backbone isn't really that necessary in this book. Okay. I wrote 4 official Microsoft courses, which are learned in Microsoft Learning Centers. So if you took a HTML5 programming course in Microsoft Learning Center, you can blame me for that course. I'm running a meetup called GDG, Google Developer Group, in my town, Rishon, and I'm co-organizer of Angular App, a conference that will be in June this year, and we run this conference for 2 years already. Okay, so if you're coming to Israel, yes, I'm coming from Israel, and you want to learn about Angular, in June we have a big conference there, and you can find me with one of the organizers. So what we're going to do in the next 45 minutes. First of all, I want to share with you some problems that we faced in the past, okay? And those problems were solved by Web Component APIs, which is the second thing that I'm going to share with you and tell you about. Okay, so if you're not familiar with Web Component APIs, then after this session, you will be familiar a little bit with those concepts. And then I'll drill down into Stencil. Stencil is a new compiler, a very interesting compiler, and I urge you to go and learn about it after this session. So let's just start with the first problem. Undescriptive markup. Do you really know what is this? What is this web page? What is it doing? We have a lot of divs, a div, and 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 a div. And we're programming like that all the time. So it looks like an arrowhead, okay? Or as it's called in a lot of conferences, the pyramid of doom, okay? So you have this pyramid of doom, and it's really undescriptive. This markup is from who knows what? Gmail, okay? This is a part of Gmail markup. So this is a big application, and we don't know what this thing is doing. Second, we have poor separation of concern. What I mean by that? So you want to create something with HTML, CSS, and JavaScript. And you want those things to work together, but you end up with a mess. Why? Because the wiring gets in your way. We need to write HTML, CSS for display and everything else, and JavaScript for behavior, and try to mix them all together into some component. Who did bundling in his project? Raise your hand, please. Raise your hand. Okay, so bundling is hard. You want to create a complex component, but how do you do that? You have CSS, JavaScript, and HTML together. Would you use a server-side concept or mechanism to bundle everything? This is what we did in the past. Or you want to use a bundler like Webpack or Browserify. You use those, yes? No. It's problematic. So, Web Component Standard to the rescue. Web Component Standards begin to be a product, or to started, I think, 4.5 years ago. It's a standard that is still built up by the W3C, the World Wide Web Conservatorium. It's the standard body for JavaScript, HTML, and etc. And what it gives you is native support for creating your own web component. There are a lot of goals in the web component APIs, for example, code reuse, encapsulation, separation of concern, theming, bundling, etc., etc. All these things, all these concepts are wrapped into 4 different standards, okay? The first one is templates. Have you ever tried to create a template in your web application? Of course, you did that. And you have a template element for reusable DOM fragments. You don't need to create a script and then load that script, and inside the script there is a template or something like that, okay? So there is a standard called templates that gives you a first-class citizen element called template in your browser. Second, imports. Imports enables you to load HTML declaratively. That means that you put a script tag or a link tag in your head, and then the rel of the script tag is import, and all the HTML that is related to that import will be loaded. More than that, it will load also CSS and HTML, not only HTML, but CSS and JavaScript as well, in one bundle. The third standard is Shadow DOM. Shadow DOM enables you to encapsulate your DOM into some shadow, okay? And this DOM won't be available to the users to see. What I mean is, have you ever used the video tag, for example? Okay, so video tag, if you will enable Shadow DOM in your user agent in your browser, then you will see the entire HTML for the video tag. But as users, you don't see that. You just see a video tag, and that's all. The last but not least is custom element. Custom elements enables you to create your own elements and present them to your browser. And this is what we are going to talk a little bit about today. Okay, I'll drill down only into custom elements. So what is custom element? The opportunity to extend or to create your own HTML elements, okay? You use the custom element.define in order to define a new element. For example, I want to define my input, then I will do window.customelements.define, and I have a new element in the browser called my input. If I want to extend the HTML input element, then all I need to do is just write window custom element.define, say the name of the element, and then what is the class that I'm going to extend. Okay? That's all. But it's not that simple. Okay? So after I did that, the browser knows that it has a new element. What next? So if you want to consume this element or to put it on the DOM, what you're going to do is one of two. First of all, you can just write my input, and you are fine. And then the browser will render your input. Second option is to use the document create element function and just say create element my input. If you define that custom element, you're good to go. What else can we do with custom elements? They have custom element lifecycle events. So you can wire into events like, for example, connected callback. When the custom element is attached to the DOM, then you have an event. Okay? You can use the disconnected callback in order to understand when the custom element doesn't have, is detached from the DOM. And every attribute change is going to have a callback. Okay, so you have an attribute change callback, and if you're changing some property in the HTML element, you can wire to this event and go forward. So with that, let's start doing some coding or coding example. So this is a web page, okay? Here's the web page. And in this web page, you can see a few things. First of all, we have a link here with the rel import that imports a template.html file. Okay, this is going to import the entire file from here, this file. Second, you can see that I have a demo collapsible, which is a new element. It's not a DOM regular element from HTML. And I have an attribute on it called data collapse header. Okay, collapse me. Also, I have an unordered list inside of it. And here is a script for webcomponent.js. Since web components aren't supported in some browser, for example, Edge, then you will need a polyfill, a library, a small library that will help you to introduce those features, and then you will use that polyfill in order to say to the browser, this is custom elements, this is how you write it, or how you use it, or this is imports, or this is templates, and et cetera, et cetera. Okay, so this is the reason why I'm using a polyfill. In most of the browsers, web components are available, but there are browsers that not support part of those features. We'll talk about it later on. So this is our web page, okay? A small web page with a collapsible panel here, and let's see how we create that collapsible panel. So in the template.html, we have a template here. This template will say how I'm going to create the HTML of that element. It also includes a lot of style here to style that element, okay? Everything is wrapped up together, and when I'm doing the import, everything will be loaded by the browser and will work. I have a script tag here that the first thing that I'm doing is grabbing the owner document for this script, okay? This will help me later on to create some behavior. So let's go on and let's create our new element. So the first thing I'm going to do is write some class. I'll call it collapsible panel. It will extend HTML element, okay? And it has a constructor that runs an init function. What is this init function? It looks like this, okay? Not very, very nice at all. First of all, I'm going to create a shadow root, okay, for the element, meaning I'm going to encapsulate the entire element inside of shadow DOM. Okay, so you do that by saying attach shadow with some mode. Then I will query the collapsible template, this template from here, okay, by its ID. I will use the API of template to clone the node and to create an instance from that template. And then I will query from that instance the header, because later on I'm going to put the title that I'm getting from the outside into this header. I will append the instance to the shadow root, and I'm just writing some few properties on my custom element, okay? Let's continue. So I'm going to wire two events. First is the connected callback, and the second one is the disconnected callback. The idea of the connected callback is to grab from the outside the title and put the title in the header, and wire event handler to bundle collapse function, okay? More than that, I'm going to wire or grab the content node, okay, which is slot content, which is this element here, okay? So once my component is attached to the DOM, I'm wiring the event handlers. I need to clean up the event handlers once the component is detached from the DOM, so this is what I'm doing in the disconnected callback. I'm removing my event handler, okay? Let's continue. The collapse function. The idea of the collapse function is just to change a property. Let's put it upper. Okay, change the property show to not show, and this content is going to be displayed accordingly. Okay, so I'm collapsing everything by the event of collapse. Last but not least, we need to wire that component. Okay, so I'll need to do custom element.define demo collapsible from my class. Voila. Saving everything and running this example. And we have a collapsible panel. Yay, components are awesome. I can collapse everything and everything is wired up and all the events will work, and hopefully you're seeing the power of custom elements, not? Let's continue. But we have problems. And we love problems, yes? You love problems? We have a very big problem today when we're developing some application. So what I mean by that? I mean by coupling or a Catholic wedding with frameworks. Who uses Angular in his daily job? Who uses React? Who uses Vue? Cool. So in companies, we have more than one team, one development team, and sometimes we develop different applications. Yes, yes. And for example, one of my customers has two different applications, one written with React, and the other one is written by Polymer. And they decided to create a third application, and they wanted to reuse the infrastructure from both of the applications, both from React and Polymer. But what's the problem? You can't do that. You can't do that because the infrastructure that they built is related or coupled into React or into Polymer. And if you want to reuse some components from one application or the other in some third application, you won't be able to do that. Why? Because you have a Catholic wedding. You have a coupling with the framework. Is that a problem? In big enterprises, yes, but in small companies, when you write everything with React or with Angular, it's cool, no? No. For example, I had a customer that acquired a different company, okay? They just acquired a company and they want to consolidate that other company's application into their own application. But a very big problem happened. Their application was written with AngularJS, and the company they acquired application was written with Angular 4. What's next? Their managers came and said, in 3 months, I want to consolidate both of the applications now. Start doing that. And they had a very big problem. What they're going to do right now? Would they migrate the entire AngularJS application into Angular 4? But they have more than 1 million lines of code written with AngularJS. Oops. So these are real problems because we want to reuse components in our applications, but once you pick a framework or a library, it will be very, very hard to do that. But there is a solution. I presented custom elements in the beginning of the session. They lift the barrier of coupling because if you create a custom element, every framework or every library can use that custom element, okay? And that's cool. This is me telling you that custom elements are very suitable for infrastructure of components, okay? But we have problems with custom elements. Dun, dun, dun. First problem, we are so hooked and used to runtime frameworks like Angular or React or Polymer that gives you virtual DOM and data binding and good performance, or bad performance, depending on how you write the application, okay? And that's cool, but custom elements do not have these things inside of it. More than that, if you want to write something in custom elements, it's very verbose. You saw me crafting a collapsible panel. You saw how many lines of code I've written? Okay, it's like 70 lines of code in order to do something that answer to event of collapse. That's sad. So we have to create everything with our hands. That's cool if you want to work hard, but that's not cool if you want rapid development. Last but not least, we have the problem of the browsers. Not all the browsers support the custom elements or even the web component API. So we need polyfills. For example, if you can see here, there is a browser in the end called Edge that considering to implement all of these standards, but it's not really there right now. So if you're aiming into Chrome, everything will work. If you're aiming into Opera, everything will work. But in different browsers, they are still considering to add the standards, okay? And that's not good for us. Really? Is there a better way? What if I told you that you can solve all these problems in one place? This is where Stencil come into place. What is Stencil? Stencil is a compiler that generates custom elements. It was written by the Ionic team. So if you're using Ionic, the whole core of Ionic is shifting into Stencil. What the compiler creates is standard compliant web components. It's not a library. It's not a framework, okay? Everything is created in design time. You compile the component that you created, and boom, you have a custom element that you can reuse in your applications. More than that, Stencil gives you a few of these buzzwords that you heard earlier. For example, it gives for each component a virtual DOM. Each component is reactively, meaning that if you have property changes and state change, that will happen as soon as possible. You write the component with both TypeScript and JSX. So if you come from a React background, it will be easy for you to adapt into Stencil. If you come from Angular background, it will also be easy to you because you have both TypeScript and you have the API of Stencil. Later on, we'll see that, and you will understand what I'm talking about. So as I said, Ionic is shifting in its entire core into Stencil components, and it's only 6 kilobytes, okay? This is the size of the entire thing, the entire Stencil when you compile things with it, okay? So it's very small, I have a very small footprint. If you want to create a Stencil component, what we are going to do is use decorators. So if you come from Angular background, you know what is a decorator. A decorator is a function, okay, that adds some content into the class. What it will add, in compile, for example, it will say create or define the element with my name. Or the style URL for this element is going to be myname.scss. Okay, so we have the decorators and the explanation or the attributes of the decorator. And then we have things like props decorator. Prop comes from property. This is the exposed attribute on this element. Okay, so I have an attribute called name. I'll expose that, and somebody that uses my-name element in the DOM can do name equals something, and something will happen. What is the something that will happen? The random function will be creating the component. with a syntax which is really, really resembling React. Why? Because underneath it's p-react, okay? There is a small React library called p-react, and Stencil is using that for the rendering, okay? So you have a virtual DOM from p-react in your component. Then, after you've written the code in Stencil, you just compile it into JavaScript. Okay, that's all. And you are generating a custom element. Then you can use it. And everything is in design time. Yeah, baby, design time. Not runtime like Angular, React, or anything else. It's just design time. So do you want to get started with Stencil? Yay! First thing to do is git clone. For example, the starter, the component starter GitHub repository, okay? You just clone it, remote rm origin to not commit to this starter, and then npm install, npm start. And you're good to go, okay? You have a working component, the same component that you saw here, okay? This is the component from their starter. Then, after you do that, you are ready to go. So I did that because I didn't think that I will have a Wi-Fi or anything else. And you can see here that I have the entire starter here, okay? It includes things like the package.json that includes a lot of configuration that were built by the Stencil team, the Ionic team, okay? I have all the details here. You have testing if you want out of the box, so you can do that for your components. They created the opportunity using Jest. And you have a built-in server inside of it that can help you to run the application or to check if the component is working, the dependencies, and et cetera, et cetera. And you have a stencil.config.js file that says how to configure the entire component, okay? Or component collection, because inside of this starter, you can create not only one component, but a component collection, okay? And then you can bundle those collections using this configuration file, okay? So doing that git clone, you get the entire thing, and you are ready to go. What are the advantages of using Stencil? So I said virtual DOM. You have a virtual DOM implemented inside of every component. You have lazy loading by default, meaning that the component will load or bundle and reload related components only when needed, okay? And that's cool. That means that if you are using only one component from a component collection, it won't load the entire collection, but rather the component that you need. You have reactivity inside of your components, meaning that if a property is changing, then the render function will run again. If the state is changing and the inner state is changing, then again, the render function will run. You have high performance rendering built-in inside of the components. The API in Stencil. So it's based on JavaScript decorators. I said that. It's written in TypeScript, and you have a few decorators that you can use in order to create your component. The first one is component. This is the main decorator. It helps you to configure the tag name that you want to use in your DOM, wire style. It can be .css, .scss if you prefer SCAS. It configures the shadow DOM. If you want to use shadow DOM, it's just put shadow true and it works. Out of the box, it's false, okay? So you don't have shadow DOM unless you say, I want shadow DOM. What is the host and the assets that you want to use inside of the component, and you're ready to go. Props and state. Both of these decorators enables you to create outside attributes using the prop decorator, or inside state of the component, and they have their reactivity, okay? Events and listen. You can wire or expose events using event emitters, okay, from the component to the outside. That means that if something happens inside of the component, you can send an event using the event emitter, say event emit, okay, and then if somebody listens to that event, it will react accordingly. How it listens to that event? Using the listen decorator or just wiring into event, because every event that a component in Stencil throws is a event. It's a custom event. Okay, so that you will be able to catch that event even if you are not really using @listen. Okay, the decorator. The element decorator enables you to grab the host element. Okay. And then you can do things like query that host or change some things in the host, okay? So you have a reference to the host element. By default, you don't have that option. If you're wiring the decorator element, you will have that option. So with that, let's create our new component, okay? I'm going to create the same component, the same collapsible component, but with Stencil. So let's get started. Okay, you can see here in the example that I have collapsible panel, and here I don't use a slot or anything else. It's just a component. Okay, let's start with the collapsible panel. So the first thing that you want to create is the component. Okay, so what I'm doing here is just adding the component here. Okay, it will have a tag called collapsible panel, style URL for style CSS that I have here. Okay, here's the style of the collapsible panel. Nothing really interesting. And I will say shadow true in order to create shadow DOM on top of this collapsible panel. Then I can wire members like the title. I'm exposing an attribute called title. You can see me using that here, okay, collapse me. And the state that will say collapse true or false. Then I can do something like adding the render function here. In the render function, I'm just creating the entire DOM, okay? The collapsible part is hidden if the collapsed property or state is true, or false, meaning it's not hidden, okay? And we have here a toggle function that I will want to create, and this is the toggle function. Okay, just this collapsed equals not collapsed. Last but not least, look at this. Something that I didn't say. Decorator method exposes that function from that component to the outside. Meaning that if I'm grabbing the collapsible panel element, this element, it will have an API function called toggle in order to collapse or not collapse that element. Okay? So with that, I can do npm run start, and if I did everything right, in the browser, we'll have the same collapsible panel now with Stencil. Yay! You're tired in the morning. Yay! Okay, so you have a component. What next? So this next thing is deploy it. You saw me talking about the stencil.config.js. This is the configuration that you are going to configure the stencil component or the stencil component collection. And you have the package.json that says things like, I'm going to run in the browser this, my name, or what are the files for the deployment. And then what you're going to do is you're just getting the output as a JS file, and you can use the JS file in CDNs, just put it in your application and go for it, or you can upload it into NPM, okay? Then NPM install that name of the component, and you have a reusable component. Cool. So how Stencil solved the framework library problem, the Catholic wedding? It runs in build time, meaning that everything is in design time. Any framework or library can consume the output, the custom elements that you are creating, whether it's in script tag or node model or whatever, okay? Any library. And this is why it's really suitable for infrastructure components, okay? You don't need to use Angular or React or anything else in order to create infrastructure components. You can create those with Stencil, and then you have custom elements which are reusable in any project that you have in your company. For example, let's consume a Stencil component from Angular. So we have here an Angular project, okay? I built the entire project from the start. And I want to consume my Stencil component, my collapsible panel. How can I do that? So I can put the Stencil folder or the component here inside of the assets for that project, okay? Once I did that, all I need to do is, one, go to the model, the main model in my application, and do something like this. Put schemas, custom element schema, meaning that I want to consume custom elements which are not created by Angular, okay? If you're not going to do that in an Angular application, won't work, okay? And then I can put the component that I created inside of my DOM. This is the template, the component template of Angular, okay? And I have here wiring to the title prop of the collapsible panel from the example earlier. And I can listen to events like any other event, okay? And then in the Angular component, I can do something like this, okay? Collapse title is going to be collapse me. And then I can add a constructor that will enable me to grab the element of the component, and then in my last function, the toggle function, I can do something like native element query selector on my component, okay? And as I said, since I added the decorator method, I can just say collapsible panel.toggle from the outside to toggle the collapsible panel, okay? And if I run this application, ng-serve, hopefully it will compile. And okay, we have the output. We can run it, and voila. Here is the Angular application. Collapse me still works because it's a custom element, and I can toggle from the outside using event handlers of Angular, doing some API calls on the custom element that I created. Okay, so it's easy as just using the component. And it's easy, there are other examples that I can show you with not just Angular, but React or Vue or any other framework. Just use those custom elements and you're ready to go. Cool. There is a session in, I think, around 1 o'clock about micro frontends. So a word about micro frontends, okay? In micro frontends, which is the problem that I presented earlier, okay, when you have 2, 3, 4, 5 teams in your company which works in different libraries and frameworks, okay, and you want to create a shared components and behavior, and you can do that because you have the Catholic wedding with the framework or the library, then you can lift this Catholic wedding or this coupling and just use shared components with Stencil, for example. So you generate Stencil components to create your shared components, and then you can consume those components from a micro app written in React, Vue, Angular, Vue, React, and etc., etc. Okay, you don't care because it's natively supported in the browser. So one of the solutions, one of the micro front-end solutions that I suggest you to consider is using web components, either the standard web component or Stencil to generate your components. So let's summarize the session. Web components is a very powerful standard, not supported by all of the browsers, but you have polyfills in order to use it. Inside of web components, you have the custom elements. They are a little bit verbose and not easy to use, so I'm suggesting to use Stencil instead of it. Stencil gives you a lot of powerful tools using TypeScript and JSX on one side, and a lot of features like virtual DOM, reactivity, and etc., etc. So this compiler is very helpful. It generates standard compliant custom elements. So you can use those elements in any library or in any framework, and that's very cool. There are a few resources that I suggest you to go after the session. The main resource is stenciljs.com. Okay, this is the page that you can find all the details about Stencil. If you want to learn about custom elements, go to MDN, the Mozilla Development Network. You can find my blog in my website, gilfink.net, or you can follow me on Twitter. I'm tweeting regularly at gilfink. With that, I want to finish this session with one sentence, okay? Either you choose web component or Stencil, just use the web platform. Thank you. If you have any questions, we have a couple of minutes that I can answer those questions, and I'll put the resources page if you want to picture it or something like that. Okay, you can find it here. Sorry, you can put it on screen. Okay, so questions. Yes. Is it possible to use Stencil in Node environment? So the answer is, out of the box, Stencil has a server-side rendering mechanism. So yes, the answer is definitely yes. You can find in the documentation in stenciljs.com a tab which includes all the configurations that you need to do in order to support server-side rendering. A good question, thank you. Any other questions? Okay, so go grab your coffee if you haven't done that yet, and thank you for coming.